we go. Okay, so I'm going to introduce our next author.
Yes, so hello everyone. Yeah.
And the number of the paper is, it's a novel, deep reinforcement learning based automatic stock trading method and case study. The number is 15708466932. Okay, thank you. Okay.
Yes, hello everyone. Yes, thank you. So my name is Yu Zhang He, and I come from Zhongli University. So I major in data science, and I'm undergraduate student. And my partner, which they are not here, so they are Yi He Li and they are Yu Chen Yang. So they also come from the same university with me, and they also major in data science. And we do our research under the guidance of Professor Peng Sun. He is a professor at data science department in Zhongli University. Yeah, that's our basic introduction of ourselves.
Okay. So I'm sharing your slides, correct? Or
Yeah.
do you want to share them?
Maybe you can share them. Thank you.
Okay.
Yeah, and play the video.
Second. Hold on. Okay, I'm sorry. My I don't know why I can't get this to work. Hold on 1 second. It's
Hello, everyone. Our topic is novel deep reinforcement learning based automatic stock trading method and case study. The goal is to predict the stock price and develop proper strategies of stock investment to help us make more profit. Our topic is meaningful, especially for the stockholders and investors, because through our method, those people can make more profit. And developing stock trading strategy is a complex and important research field related to the investment. Typically, the stock trading is a multi-criteria decision-making process. Simply put, when we trade stocks to maximize returns, we often need to consider the impact of a variety of factors, such as the type of stock to be traded, the trend of the corresponding stock price, the market trend, the specific moment of buying and selling, the specific volume of the stock for trading, and so on. In addition to direct factors such as price, the risk of stock trading may also be affected by other indirect factors, such as the financial reports reflecting the business state of the company, policy changes of the relevant market supervision departments.
We weren't seeing the video.
Okay, I'm sorry. I'm going to restart that again. I'm sorry. I keep losing my window when it starts. So I'm really sorry.
So hello everyone, our topic is novel learning based automatic stock trading method and case study. The goal is to predict the stock price and develop proper strategies of stock investment to help us make more profit. Our topic is meaningful, especially for the stockholders and investors, because through our method, those people can make more profit. And developing a stock trading strategy is a complex and important research field related to the investment. Typically, the stock trading is a multi-criteria decision-making process. Simply put, when we trade stocks to maximize returns, we often need to consider the impact of a variety of factors, such as the type of stock to be traded, the trend of the corresponding stock price, the market trend, the specific moment of buying and selling, the specific volume of the stock for trading, and so on. In addition to direct factors such as price, the risk of stock trading may also be affected by other indirect factors, such as the financial reports reflecting the business state of the company, policy changes of the relevant market supervision departments, and so on. Obviously, due to the joint influence of those various direct and indirect factors, the stock market is characterized by highly dynamic, further increasing the difficulty of designing the stock trading strategies. And here is the outline of the presentation. In our project, we want to combine autoencoder long short-term memory to predict the stock price and reinforcement learning method to develop the stock trading strategy, including a strategy for trading just one stock and strategy for trading multiple stocks simultaneously. So we first used LSTM to predict the stock price, and second, we used the reinforcement learning method to develop the stock trading agent. We used the double deep Q network, which is a reinforcement learning method to train the single stock trading agent. And we use another reinforcement learning method called the twin delay deep deterministic policy gradient to train the multi-stock trading agent. So before we start, we have read several related literatures. For predicting the stock price, there have been many methods. Since the stock price is time series data, some people may use the ARIMA to make prediction. Since there may exist seasonal factors in stock price, some people also use the SARIMA model to make the stock prediction. Still, the stock prices also contains noise and nonlinear trend. The ARIMA and SARIMA are linear statistical models, which are only good at making a short-term prediction. So therefore, to better reduce the influence of the noise and the nonlinear information, some people have used the hybrid model such as the SARIMA SVR approach. However, since the stock price is a time series data, where the previous data have influence on current data, therefore, to utilize the past information, recurrent neural networks were adopted to make the stock prediction. However, some people have used a kind of improved RNN called the long short-term memory, which is LSTM to make the stock prediction. Because compared with RNN, LSTM has a forget gate, which can filter out useless past information. Therefore, we use LSTM to make stock price prediction. And we also review the literature related to the reinforcement learning. The stock trading environment is very complex. People may consider how many stock shares need to buy or sell each time, as well as the remaining cash when they want to trade. Therefore, people use the reinforcement learning method to make the trading strategy. We classify reinforcement learning method based on the action states, which can be classified into discrete and continuous action space. So why we distinguish in this way will be discussed later in our presentation. Some people use deep Q network with discrete action space to make trading strategy, and some people use the deep deterministic policy gradient and improve the reinforcement learning method based on DDPG. With continuous action space to make the trading strategy. So let's discuss the method that we use. So we first use the LSTM model for stock price prediction. The LSTM model is composed by 2 layers of LSTM network and 2 dense layers. The first layer of LSTM network has 128 cells and 60 time steps, and the second layer of LSTM network has 64 cells and 1 time step. The first dense layer has 25 cells, and the second dense layer has only 1 cell. So we put the predicted stock price into the pre-trained trading agent, and then the pre-trained trading agent will make the trading decision. And now let's welcome my teammate to discuss the following part.
Hello everyone, I will introduce the reinforcement learning part. as the picture shows the general structure of the reinforcement learning. There is an agent and environment, and based on the state of the environment, the agent makes an action. And based on the action, the environment will give back a reward to the agent. And based on the reward, the agent will adjust its policy and makes the optimal decision. The advantage of reinforcement learning compared with other machine learning algorithms is that it can gain experience or rewards from their actions to improve the policy and develop optimal policy in a complex environment. Therefore, we choose the reinforcement learning method to automatically learn from the environment and make training decisions. There are many important components of the reinforcement learning. The first important component is the definition of action space. In our case, we make the definition of action space shown below. Here, B denotes the buying decision and BP is the expenditure of the corresponding per cache as a percentage of the available cash flow. And the selling decision is represented by S, and SP is the percentage of stock held for scale as a percentage of existing stock holdings. And H denotes the holding decision. And we also define the reward function of reinforcement learning. And we define reward as the difference between the total amount of assets after the end of 2 consecutive training actions. The total amount of assets at time t is defined as above equation. Here, fund is the remaining cash, and the stock inventory means how many shelf stocks we hold in this decision. And to avoid the agent being held in the holding state, to minimize the trading risk, we introduce a negative reward to force the agent to initially trade some stocks, and when the stock holdings are 0. After it, the agent can freely decide whether it will buy, sell, or hold in the future. And the most important of reinforcement learning is the choice of function approximation. In our design, we adopt DDQN, the double deep Q network, and TD3, twin DDPG as the approximation function model for better fitting the characteristic of individual stock trading and multiple stocks trading scenarios respectively. We will discuss why we made this decision in the later part of the presentation. Let's continue. So in single stock case, we choose the improved version of DQN, the DDQN. The advantage of DQN is that it can use neural network to replace Q-table in the Q-learning. Therefore, it can save memory and reduce computation time. And it also works well in discrete action and state space. Since in the single stock trading scenario, for one stock, we only need to consider the 3 actions: sell, buy, and hold. And the double DQN makes improvement by adding a target network on the original DQN model. Therefore, the model is more stable. And we also make some improvements related with the input state of our DQN model. The trading decisions were based on the growth trend of stock price data. And we can enable our model to sell or buy non-equal amounts of stock each time. Therefore, in the situation when we want to buy a stock, but the remaining cash is lower than the price of 1 share of stock, you can still buy the stocks. And here is the pseudo code for our DDQN algorithm. And let's continue with the multiple stock trading case. In this case, we choose the TD3, whose action space is continuous. The reason is that if the action space is discrete, and there are n stocks, so the total amount of action space is 3 to the power of n. It will grow exponentially. Therefore, we choose TD3 with a continuous action space. And TD3 is an improved version of deep deterministic policy granting method. DDPG has 4 networks, including actor network, actor critic network, target network, and target critic network. TD3 further added one more actor critic network and a target critic network to avoid the overfitting problem caused by the DDPG. And TD3 also introduced delayed policy update and the target policy smoothing technique to solve the overestimation problem of DDPG. The last point is that we make innovative improvements by using ND index, percent change, and moving average of stock price each day as a technical indicator in the input state. Moreover, we input the T3 model by CV model parameters, which can bring the best training result among all training assets to avoid the OST estimation problem in case that after many trials of update, the overestimation problem may occur. And here is the pseudocode for our TD3 algorithm. And we reach to the performance evaluation part. Here is the dataset of our project. We use the stock of Google and Apple as the dataset. In single stock case, we train on the Google and stock data set each. And in multi-stock case, we simultaneously do the training decision on the two stocks. And here's the results. The first is the realization result of training policy on the test dataset of Google stock. From the figure, we can see that the picture shows that the agent generally learns the principle that buy the stock when the price is low and sell the stock when the price is high. And the dotted points are predicted stock price. We can see that the LSTM model generally learns the basic trend of the Google stock. And here is the realization result of training policy on the test dataset of Apple stock. You can see that the result is similar. And here is the realization results of multiple stock trading policy on the Google stock and Apple stock. And here is the conclusion and the future work. We can see that LSTM basically make a good prediction, and reinforcement learning methods such as DDQN and T3 also generally learn the principle of trading stocks. And we can make some improvements in the future. For example, we can apply natural language processing to incorporate people's expectation into the state place. And we also allow the trading agent to trade multiple times in a day. And we can also adopt other methods for prediction, such as generative adversarial network. Thank you. Any questions?
Hey, does anybody have any questions?
So hello everyone. Our
Yes.
topic is
Sorry. No questions from anyone? Trying to think of a good question for you. The prediction, I mean, they look very accurate from the last few charts that you showed us. Did you find that, have you done other research using other methods to see if they were as accurate?
Yes, we have already done some other researches for maybe predicting the stock price. So for example, we have used some statistical methods such as ARIMA and SARIMA, but we think first it can maybe only predict the stock price at a short time. So maybe just a couple of weeks ahead of the time. So I think it is not suitable for predicting maybe the longer trend of the stock price. And also maybe it cannot maybe filter out the noise in the stock price. So we think maybe STM is a better model compared with some traditional statistical models. And we may also apply some advanced models such as GAN network to do the stock price in the future.
Oh, okay. All right. Well, thank you very much. And thanks for bearing with me in the beginning too, with the video. Yes, I've been having lots of problems with my laptop, but thank you. That was the timer. So right on time. Thanks. Okay, so now we're going to go on to the final paper. Umit, I don't think is here online, or is someone else presenting from the paper that Umit was part of for the metaverse? That's in the audience? I think Umit was actually scheduled, but I didn't know if maybe somebody else from his team had decided to present instead. I don't think so. Okay, so I'm going to